Hello friends, welcome to Event Academy. In the last lecture we have discussed up to question number 7. So we will discuss question number 8 onwards in this particular lecture. So basically we are discussing the problems on the strings in 2 dimensions. So this is set 3. Okay, so let's start our discussion. So what is given in question number 8? Okay, so we have a uniform chain of length L is suspended from 2 points A and B in the same horizontal line. Okay, so we have the uniform chain. It is suspended from 2 points. This is point A and this is point B in the same horizontal line. If the tension at A, let us consider the tension at point A is T. Tension at A is twice that at the lowest point. So let us consider the tension at lowest point is T naught. So the relation is T is 2 times of T naught. Okay, so we have to show that. To show, we have a span AB. Span AB is equal to 1 by root 3 log of 2 plus root 3. This we have to show. Okay, so what we have seen in the previous lecture is that if the relation is T is equal to n times of T naught, so tension at point A is n times of tension at the lowest point, we have the relation as span is equal to 1 upon n square minus 1 under root log of n plus root under n square minus 1. Okay, so we have in this particular question we have the relation as T is equal to 2 times of T naught. Okay, so we have for this particular question n is equal to 2. So let us place the value n is equal to 2. So the span is equal to 1 upon 2 square minus 1 under root log of 2 plus root under 2 square minus 1. So this is equal to 1 upon root 3 log of 2 plus root 3. Okay, so this is the value of span. Okay, so now let us discuss question number 9. A uniform chain of length L which can just bear a tension of n times its weight, okay, is stretched between 2 points on the same horizontal line. Okay, so let us draw the horizontal. This is the horizontal line. Okay, and a uniform chain is stretched between those 2 points. Okay, so that the least possible sag. Okay, so that to show least possible sag is equal to L times of n minus root under n square minus 1 by 4. This we have to show. Okay, so how we can show this? What is given in the question is that the maximum value of the tension T max is equal to n times its weight. Let us consider the weight per unit length is small w. Okay, so the weight of the chain will be w times of length. Okay, so T max is equal to n times the weight of the chain. So n times of WL, that is NWL. NWL is the value of the maximum tension. NWL. Okay, so this is the value of maximum tension. Okay, so we have the relation tension at any point is given by, we have studied that tension at any point is proportional to the ordinate. Okay, and we have tension is equal to weight per unit length times of ordinate. Okay, so when T is equal to T max, when Y is equal to YA. Okay, because tension is directly proportional to the ordinate, so the maximum value of Y is YA. Okay, so this is our directrix. So tension at any point is proportional to the ordinate. This is Y. So the maximum tension will be here T max, because ordinate will be maximum at this particular point, that is YA. Okay, so based on this relation we have TA is equal to W times of YA. Okay, so TA is T max, so T max is equal to W times of YA. Okay, so let us equate this. So n times of, this is equation 1, let us take this as equation 1 and this as equation 2. So we have NWL is equal to W times of YA. This gets cancelled, so we have YA is equal to NL. Okay, also we have the relation as y square is equal to s square plus c square. Okay, so when y is equal to YA, we have s is equal to L upon 2. Okay, so arc length is s. So at this particular point we have S is equal to L upon 2 because the length of the chain is L. Okay, so this whole length is L. This whole length is L. So half of the length is L upon 2. So S is equal to L upon 2 when Y is equal to YA. So we have YA square is equal to L upon 2 whole square plus C square. So from here we have YA square is equal to L square upon 4 plus C square. Okay, and YA is equal to NL. So from here N square L square is equal to L square upon 4 plus C square. Okay, so from here we have C square is equal to L square N square minus 1 upon 4. So from here C is equal to, let us further simplify this. So from here we have C is equal to L square. Let us further simplify this expression. So L square N square minus 1 by 4 under root. So we have C is equal to L times of root under N square minus 1 by 4. This is the value of C. So we have to show that the least possible sag is the at the middle is given by this particular expression. So let us find this. How we can find this? Okay, this length this value is C. C is the distance of directrix from the lowest point. Okay, and this is YA. Okay, so this particular length is sag is equal to YA minus C. Okay, so sag is equal to YA minus C, and YA is equal to NL and minus C. C is given by L times of root under N square minus 1 by 4. So this is equal to, let us take L common, L times of N minus root under N square minus 1 by 4. This is the value of sag. Okay, let us discuss question number 10. A given length 2s of a uniform chain has to be hung between 2 points in a same level, and the tension has not to exceed the weight of a length b of the chain. Show that the greatest span is given by this particular expression. How we can solve this? So we have the common catenary like this. Okay, and this is our axis. So given length is 2s. So this is s. This is also s. Okay, and the maximum value of the tension we have seen in the previous lecture is that it is at extremity. So this is T max, and T max is equal to tension has not to exceed weight of length b. So this is and weight per unit length is small w. So the weight of length will be small w into b. So this is small w into b, and tension is proportional to the ordinate. This means tension at point A is proportional to YA. This means tension at A is equal to W times of YA. Okay, and this tension at A is T max. Okay, this is T max. So from this particular expression and this particular expression, WB is equal to W times of YA. So this gets cancelled. This means YA is equal to B, and we have the relation as Y square is equal to S square plus C square. So at point A, Y is equal to YA. So YA square is equal to, and at Y is equal to YA we have S is equal to S. Okay, so half of the length is S, so this is S square plus C square, and YA is B. So B square is equal to S square plus C square. So from here C is equal to B square minus S square under root. Okay, this is the value of C. समझ में आ रहा है? So that the greatest span. So we have studied that the span length, that is XA, X is equal to given by, let us Let us write down the expression for the x coordinate. Okay, so x is equal to c log 6i plus 10 psi. Okay, so at this particular, so xa will be equal to, xa is the distance of this extremity, that is point A from the axis. So xa is equal to c log 6ia plus 10 psi a. Okay, so we have a span length. Span is equal to 2 times of xa. So span is equal to 2c log, this we can write as, let us multiply by c and divide by c. So c 6ia plus c 10 ia. Okay, upon c. Okay, and we have the expression as y is equal to c 6i and s is equal to c 10 psi. Okay, let us calculate ya. So ya will be c times of, for this let us put 6 ia and s is equal to, at point A we have s is equal to s, so s is equal to c 10 ia. Okay, so this is ya, c 6 ia is ya and c 10 ia is s. So we have span is equal to 2c log, and ya, value of ya is b, so this is b. So c 6 ia is b, so this is b, plus c 10 ia, this is s, upon, and value of c is b square minus s square, so this is under root b square minus s square. Okay, and value of c is this one. Let us further simplify this. So we have span is equal to 2 times of, value of c is this one, b square minus s square log of b plus s upon, this is b minus s square, this is root under b plus s, root under b minus s. So this is equal to 2 times of root under b square minus s square log of, this we can cancel this, so this cancels to root under b plus s, so this is equal to b plus s upon b minus s ka half. Okay, so let us further simplify this. Okay, so we have this as span is equal to 2 times of half we can take out here, root under b square minus s square log of b plus s upon b minus s, so this gets cancelled, so we have the span as, so we have a span is equal to root under b square minus s square log of b plus s upon b minus s. This is the value of greatest span. Okay, now let us discuss question number 11, how we can solve this. If alpha and beta be the inclinations to the horizontal of tangents at the extremities of a portion of a common catenary, and L the length of this portion. Okay, extremities of a portion of a common catenary, of a portion, extremities of a portion. Okay, so let us draw the common catenary like this. Okay, so we have 2 points, let us take 2 points as P and Q. Okay, so the inclination of alpha and beta with the inclinations to the horizontal. Let us draw the tangent at these 2 points. Okay, so this inclination is alpha and this inclination is, inclination of tangent at point Q is beta, inclination of tangent at point P is alpha. Okay, and this PQ, arc PQ is length L. Okay, show that the height of one extremity above the other. Let us consider this height of one extremity above the other is small h, and we have to show that this small h is equal to L times of sine of half of alpha plus beta upon cos of half of alpha minus beta. Okay, so this we have to show. Okay, so let us draw this once again. So we have the common catenary like this. 2 points we have, this is P and this is Q. So tangent at these 2 points make an angle. Tangent at these 2 points, this is tangent at point P. Let us consider what is given in the question, alpha and beta be the inclination. This inclination is alpha. And tangent at point Q makes an angle beta. Okay, and this arc length PQ is L from here to here. And we have to show that this H, let us consider this as H is given by this particular expression. Okay, how L times of sine of alpha plus beta by 2 cos of alpha minus beta upon 2. Okay, so this H is the height of one extremity over other. So height of point P above Q. This is the value of H, and this we have to show that this is given by this particular expression. Okay, so we have the relation as, okay, let us consider this as directrix. Okay, now let us take this as, let us take this point as YQ, and this point P is at a distance of YP from the directrix. Okay, and this is the axis. So we have the value of length L is equal to arc. Let us consider the bottommost point as C. So arc CP minus arc CQ. Okay, so S is our arc length and S is given by, S is equal to C tan psi. S is equal to C tan psi. Okay, so this arc length, so arc, so we have this as arc CP will be equal to arc CP. So this is value of psi at point P is alpha. Okay, so this is equal to C tan psi P, angle at point P, minus C times of tan of psi Q. Okay, so psi Q is equal to, psi Q is equal to beta and psi P is equal to alpha, is equal to C tan alpha minus C tan beta. This is the value of L. So L is equal to C times of tan alpha minus tan beta. So we have the value of C as L upon tan alpha minus tan beta. This is the value of C. Okay, and we have the height of one extremity above the other. Okay, let us calculate that also. So we have the relation in the ordinate as y is equal to c sec psi. Okay, so the value of height of one extremity above the other, so h is equal to yp minus yq. Okay, so at point P inclination is alpha, so we have c sec psi p minus c sec psi q. Okay, this is c sec psi p is, this is psi p and this is psi q beta. So this is c sec alpha minus c sec beta. This is h. So h is equal to c times of sec alpha minus sec beta, and this is the value of L. So h is equal to, sorry, this is the value of C. Let us place C from here in this particular expression. So this is L times of sec alpha minus sec beta upon tan alpha minus tan. Okay, let us further simplify this. Sec alpha minus sec beta upon tan alpha minus tan beta. So we have h is equal to L times of sec alpha minus sec beta upon tan alpha minus tan beta. Okay, so h is equal to L times of 1 upon cos alpha minus 1 upon cos beta upon, this is sin alpha upon cos alpha minus this is sin beta upon cos beta. So this is equal to L times of cos beta minus cos alpha upon sin alpha cos beta minus cos alpha sin beta. Okay, so this we can further simplify. L times of, this is 2 times of sin alpha plus beta by 2 into sin of alpha minus beta upon 2 cos beta minus cos alpha. The expansion of this is this particular expression upon, this is written as sin of alpha minus beta. Okay, so we have sine of 2x is equal to 2 sin x cos x. This we can write as sine alpha minus beta, we can write as sine of 2 times of alpha minus beta upon 2. Okay, so let us expand this using this particular expression cos x. So we have h is equal to L times of 2l sine alpha plus beta upon 2 sine of alpha minus beta upon 2 upon 2 sine alpha minus beta by 2 cos of alpha minus beta upon 2. This gets cancelled, 2 gets cancelled. So this is equal to L times of sine of half alpha plus beta upon cos of half of alpha minus beta. Okay. Now let us discuss question number 12. How we can solve this? So ends of a uniform chain slide along a fixed rough horizontal rod. Let us consider a rod like this. Okay. So we have ends, the end lengths of a horizontal chain slide along a fixed rough horizontal line. Prove that the ratio of maximum span to the length of the chain is given by this particular expression. So we have this as the links as that. This is our catenary. So end links of a uniform chain slide along a fixed rough horizontal line. Prove the ratio of maximum span to the length of the chain. Maximum span upon length of chain is given by this particular expression. Okay. Let us draw the figure again. Solution. Okay, so this is our rod. Okay, let us draw the chain like this. Okay, let us consider the reaction at this point. Let us name this as point A and this point B. The reaction at point A is R. Okay, and we have the coefficient of friction as mu. So the friction will be mu times of R. And let us consider the resultant force as F. Okay, and let us consider this resultant force makes an angle of alpha with the value of make an angle alpha with the normal reaction. Okay, so we have tan alpha is equal to coefficient of friction. This we have already studied in the chapter of friction. So tan of alpha is equal to mu. This means cot of alpha is equal to 1 upon mu. Okay, so let us name this angle as psi a. Psi a is equal to pi by 2 minus alpha. Okay, what is given in the question? Prove that the ratio of maximum span to the length of the chain. Okay, so obviously since tension is proportional to the ordinate, so tension will be maximum T is equal to T max when Y is equal to YA. Okay, so we have the span length. Span is equal to 2 times of x. This is equal to 2c log 6 IA plus 10 IA. Okay, so now let us calculate the value of 10 IA. So 10 IA is equal to tan of pi by 2 minus alpha. So this is equal to cot alpha. This is tan psi a. Okay, so this we can further simplify this. This is 2c log 6 psi a we can write as 1 plus tan square psi a under root plus tan psi a. Okay, and tan psi a is equal to cot alpha, and cot alpha is equal to 1 upon mu. So this is equal to 2c log under root 1 plus tan psi a is cot alpha, and cot alpha is equal to 1 upon mu. So this is 1 upon mu square plus 1 upon mu. Let us further simplify this. This is span. So span is equal to 2c log of this we can write as 1 plus this is 1 and 1 plus mu square root under plus 1 upon mu. Okay, so we have this expression like this. So span is equal to 2c log of this we can further write as span is equal to 2c log of 1 plus root under 1 plus mu square upon mu. Okay. Now at point A we have at point A we have y is equal to c sec psi a. Okay. So at point A we have let us consider the length of the chain as 2L. So this is L and this is L. Half of the length is L. Okay. So at point A y is equal to c sec psi and s is equal to c tan psi. Let us further simplify this. So we have the expression as s is equal to c tan psi. Okay, so at point A we have the value of s as L. So L is equal to c tan psi a, and value of tan psi a is value of tan psi a is cot alpha. This is equal to c cot alpha, and cot alpha is 1 upon mu. So this is c upon mu. So L is equal to c upon mu. So this means c is equal to L mu. Okay, so let us place the value of c as L times of mu. So span is equal to 2L times of this is mu log of 1 plus root under mu square plus 1 upon mu. So we have the value of a span. Let us take this as 2L here. So span is equal to, let us write down this expression. So span is equal to 2L mu log of 1 plus 1 plus mu square upon mu. Okay. So we have to find the ratio of a span to the length of the chain. So length of the chain is 2L. So let us take 2L here. So span upon 2L is equal to mu times of log of 1 plus root under 1 plus mu square upon mu. Okay, so this is the ratio of maximum span to the length of the chain. Okay, now let us discuss question number 13, how we can solve this. So if the ends of a uniform inextensible string of length L hanging freely under gravity slide on a fixed rough horizontal rod whose coefficient of friction is mu, so that at most they can rest at a distance mu L times of log 1 plus mu square. This is similar to the previous question. So we have calculated the span as is equal to so in the last question we have taken the length of the chain as 2L. Okay, so in this particular question we have the length of the chain as L. So let us replace 2L with L. Okay, so this particular expression will become span is equal to L times of mu log of 1 plus root under 1 plus mu square upon mu. Okay, based on the last question. So we have span is equal to mu world. So in the last question we have considered the length of the chain as 2L. So we have found the span as 2L times of mu log of 1 plus root under 1 plus mu square upon mu. So in this particular question we have the length as L. So we have span is equal to L times of mu log of 1 plus root under 1 plus mu square upon mu. Okay, so this is the value of span. Now let us discuss question number 14. How we can solve this? The extremities of a heavy string of length 2L and weight 2Lw are attached to a small rings which can slide on a fixed wire. Each of these rings is acted upon by a horizontal force equal to Lw, so that the distance apart of the ring is given by this particular expression. So let us consider the tension at the lowest point is T naught, and each of these ring is acted upon by horizontal force. So the horizontal force is given by horizontal forces. Each point is equal to the tension at the lowest point. Okay, so we have the value of T naught is equal to tension at each of these point. Okay, So the tension at what is given in the question, each of these rings is acted upon by a horizontal force, and horizontal force is equal to Lw. This means T naught is equal to Lw. Okay, and we have the span, value of span is equal to 2 times of xa. This is equal to, suppose this is xa. Okay, so this is equal to 2 times of C log 6 Ia plus 6 Ia plus tan of psi A. Okay, the length of the chain is 2L. So we have the value of S as S is equal to C tan psi. So when at point A we have, let us apply this expression at point A. So this is point A and this is point B. So point A is the extremity. So at point A we have S is equal to L and psi is equal to psi A. So we have L is equal to C tan psi A. Okay, C is equal to L is equal to C tan psi A. And we have studied that the value of tension at the lowest point is equal to weight of C length of the string. This means T naught is equal to WC. So Lw is equal to WC. This means value of C is equal to L. So from here L is equal to, let us put C is equal to L. So L is equal to L times of tan psi A. This means tan of psi A is equal to 1. This means psi A is equal to 45 degree. So let us place psi A is equal to 45 degree in this particular expression. Let us further simplify this. So we have the span is equal to span is equal to 2c log, and value of c is L. So 2L log of 6 Ia. So psi A is 45 degree and psi A is also 45 degree. So sec of 45 degree is root 2 plus tan of 45 degree is 1. So we have span is equal to 2L log of 1 plus root 2. Okay, so we have discussed up to question number 14. So this is all about the problems on the strings in 2 dimension. Okay, thank you.